Welcome to MRL. In this learning session, we will learn a few very important theorems related to similar triangles. This is the fourth part of study of similar triangles. Now we have a theorem here. In a right angled triangle, the perpendicular drawn from the right angled vertex to the hypotenuse divides the triangle into two triangles which are similar to each other and to the given triangle. Let us understand the meaning of this statement first. Now there is a triangle ABC which is a right angled triangle. Angle B is 90 degrees. A perpendicular is drawn from the right angled vertex BD to the hypotenuse AC. Now two new triangles are formed, that is triangle ABD, triangle BCD. So ABD and BCD are two new triangles. These two new triangles formed are also similar to each other and similar to the given triangle ABC. So this is a very important theorem because this theorem is used in proving the Pythagoras theorem on the basis of similarity of triangles. Now let us understand this theorem, prove this theorem, and then proceed further. Now what is given to us? We are given a triangle ABC. Angle B is 90 degrees, BD is perpendicular to AC. Now we have to prove that triangle ABD is similar to triangle BCD and similar to triangle ABC. Now it is enough for us to prove that the three angles of each triangle are correspondingly equal. So let us understand the proof. In triangle ABD and triangle BCD, we see that angle A and angle B. Now purposely I have taken as angle A and angle B here. Actually angle B means here DBC. I have not taken angle DBC, I have taken as angle B itself and angle A here. So angle A and angle B are equal to theta. So this is theta, this is theta. Therefore both angles are equal. That is angle A is equal to angle B is equal to theta. Now if you take angle B and angle C, if you take angle ABD, they take the angle B here, that is 90 minus theta. Angle C is also 90 minus theta. Therefore these two angles are also equal in these two triangles. That is what I have written here. Angle B is equal to angle C is equal to 90 minus theta, and angle D is equal to angle D. Now this is 90 and this is 90. This is angle D of this triangle, this is angle D of this triangle. Both are equal to 90 degrees. That means the three angles of this triangle, that is ABD and BCD, are correspondingly equal, and therefore by AAA similarity these two triangles are similar. So now we have proved that triangle ABD and triangle BCD are similar by AAA similarity. Now let us consider triangle BCD. Let me take triangle BCD and triangle ACB. BCD and ACB. Let us compare the angles. Now if you see, angle B is theta here, angle A is theta, therefore angle B and angle A are equal, and that is theta. Angle C is 90 minus theta, and also angle C is 90 minus theta. We have got angle C 90 minus theta for angle BCD and also for angle ABC, that is 90 minus theta. Now angle D is 90 degrees and angle B is 90 degrees, that is equal to, that is what I have shown here. So by AAA similarity, triangle BCD is similar to triangle ABC. Now from 1 and 2 we have triangle ABD is similar to triangle BCD and triangle BCD is similar to triangle ACB, and therefore all these three triangles are similar, and that is the proof of this particular theorem. And this theorem is used to prove the Pythagoras theorem and is a very important part of the proof of the Pythagoras theorem. So this is the theorem by itself and also a part of the Pythagoras proof of the Pythagoras theorem. So remember this theorem. Now let us go to the next important theorem, that is the proof of Pythagoras theorem. Already we know what is Pythagoras theorem. Now we have to prove it. Let us see how to prove it. Now we are given a triangle ABC where angle B is 90 degrees and AC square is equal to AB square plus BC square. This is what we have to prove actually. So this is the Pythagoras theorem, that is AC square is equal to AB square plus BC square, and we have to prove it on the basis of similarity of triangles. Now let us go for the construction. Draw BD perpendicular to AC. When you draw BD perpendicular to AC, just now we have learnt that the two triangles formed and the triangle ABC are all the three are similar. That means triangle ABD is similar to triangle BCD and similar to triangle ACB. Just now we have proved this, and that is exactly the first part of this particular proof of Pythagoras theorem. Therefore we have three triangles similar, and if the three triangles are similar, then then the corresponding sides of the triangles will be proportional. So let us take the first two triangles, that is triangle ABD and ACB. So triangle ABD and triangle ACB, they are similar, therefore the corresponding sides are proportional. That means AB upon AC, AB upon AC is equal to BD upon BC is equal to AD upon AB. So the three sides are proportional. Now let us take the ratio AB upon AC and AD upon AB. AB upon AC and AD upon AB. I have taken these two ratios because in the proof I have to get AB square. So by cross multiplication I get AB into AB square is equal to AC into AD, that is 1. Now let us go for the next two pairs, that is BCD and ACB. Triangle BCD and triangle ACB are similar, therefore I have written here. Now take their corresponding sides are proportional, that means BC upon AC is equal to CD upon BC is equal to BD upon AB. Now I want BC square, therefore I have taken BC by AC and CD by BC. By cross multiplication we get BC square is equal to AC into CD. So we have one, that is AB square is equal to AC into AD, and we have two, BC square is equal to AC into CD. Now we want AB square plus BC square, so adding 1 and 2 we get AB square and BC square on LHS. So AB square plus BC square is equal to AC into AD plus AC into CD. AC is common in this, take AC outside, in the bracket AD plus CD. But what is AD plus CD? AD plus CD is again AC, so replacing this by AC, AC into AC is equal to AC square. Therefore AB square plus BC square is equal to AC square, and that is the proof of the Pythagoras theorem. So this is how we use the similarity of triangles properties to prove the Pythagoras theorem. So please remember this. Now the next important theorem is the converse of Pythagoras theorem. So let us learn the converse of Pythagoras theorem. We already know what is the statement. The statement is very simple. In triangle, if AC square is equal to AB square plus BC square, then angle B is equal to 90 degrees. Therefore triangle ABC is a right angled triangle. So let us learn this theorem. So let us proceed with the proof. Now we are given a triangle ABC. We have to prove that AC square is equal to it is given to us AC square is equal to AB square plus BC square, that is given to us. Now we have to show that angle B is equal to 90 degrees, so that triangle ABC is a right angle triangle. Now construction is, draw another triangle PQR where right angle triangle PQR where angle Q is 90 degrees. PQ is equal to AB and QR is equal to BC. Okay, remember that. Now in triangle PQR, PR square is equal to PQ square plus QR square by Pythagoras theorem, because the angle is 90 degrees, it is a right angle triangle, PR is the hypotenuse, therefore PR square is equal to PQ square plus QR square. But PQ is equal to what? AB, so I can replace PQ square by AB square. And what is QR? QR is BC, I can replace by BC square. So PR square is equal to AB square plus BC square. But we know that AC square is equal to AB square plus BC square, that means RHS of this and this is same, therefore I can replace PR by AC, that means it will be AC square is equal to AB square plus BC square. So now if AC square is equal to AB square plus BC square and PR square is equal to AB square plus BC square, therefore the PR square is equal to AC square or AC is equal to PR. So now we have proved that AC is equal to PR. Now in these two triangles, that is triangle ABC and triangle PQR, AB is equal to PQ is by construction, and BC is equal to QR by construction, and AC is equal to PR just now we have proved. Therefore by triple S congruency criteria, these two triangles are congruent. If two triangles are congruent, then the corresponding angles are equal. Therefore angle B is equal to angle Q, rather angle Q is equal to angle B. Angle Q we know it is 90 degrees, therefore angle B is also equal to 90 degrees. And because angle B is 90 degrees, triangle ABC is a right angle triangle, and that is exactly what is the proof of converse of Pythagoras theorem. So please try to remember this, okay, and it's a very important proof. Now we have to learn the areas of similar triangles theorem. The theorem states the ratios of the areas of similar triangles is equal to the ratio of the squares of their corresponding sides. Again I'll repeat, the ratio of the areas of similar triangles is equal to the ratio of the squares of their corresponding sides. Now what is the meaning of this statement? Now there are two triangles ABC and PQR, they are similar. the ratio of the area of these two triangles, that is triangle ABC and triangle PQR, is equal to the squares of their corresponding sides. That means area of triangle ABC divided by area of triangle PQR is equal to BC square upon QR square, or AC square upon PR square, or AB square upon PQ square. So that is what is the meaning of the statement. Now let us see how to prove this. Let us understand this and let us prove it. Now we are given triangle ABC and triangle PQR. Angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, and also AB upon PQ is equal to AC upon PR is equal to BC upon QR, because these two triangles are similar. So that means corresponding angles are equal, corresponding sides are proportional. Now we have to prove that area of triangle ABC divided by area of triangle PQR is equal to BC square upon QR square. So here I have taken one pair of corresponding sides, that is BC and QR. We can also prove, we can also take AC and PR or AB upon PQ, but since it is very clearly visible to us, BC and QR are more clearly visible, and therefore I have taken BC and QR. That therefore area of triangle ABC upon area of triangle PQR is equal to BC square upon QR square is what we have to prove. Now construction: draw AD perpendicular to BC, draw PS perpendicular to QR. Now area of triangle ABC divided by area of triangle PQR is equal to half into base, half into BC into AD, half into base into height, that is half into BC into height, that is AD. Similarly, the area of the triangle PQR is half into base QR into height PS. Okay, now half will cancel, we get BC upon QR is into AD upon PS. So we get BC upon QR into AD upon PS. Let us call this as 1. Now we have two triangles here, triangle ABD and triangle PQS. Now if you observe these two triangles, angle B and angle Q are equal because they are corresponding angles, because the two triangles are similar. Angle D is equal to angle S is equal to 90 degrees by construction, and the third angle, that is angle BAD and angle QPS, are also equal. Therefore by AAA similarity, triangle ABD and triangle PQS are similar. That's what I have written here. If the two triangles are similar, then their corresponding sides are proportional. Therefore AB upon PQ is equal to BD upon QS is equal to AD upon PS. Now if you look at this AB upon PQ is equal to BC upon QR, AB upon PQ is equal to AD upon PS. That means from this 1 and 2 here, we see that AD upon PS is equal to BC upon QR. Again I'll repeat, AB upon PQ is equal to BC upon QR, AD upon PS is also equal to AB upon PQ, and therefore AB upon PQ being equal to BC upon QR, AB upon PQ being equal to AD upon PS, AD upon PS is equal to BC upon QR. So I can replace this AD upon PS as BC upon QR in here, in this relation, that is area of triangle ABC upon area of triangle PQR is equal to BC upon QR into BC upon QR. It is BC square upon QR square. So BC square upon QR square is what we have wanted to prove, and that is what we have proved. Therefore the ratios of the area of two similar triangles is equal to the ratio of the squares of their corresponding sides. So this is what is the proof. And remember, we also can take the other two ratios. It can be AC square upon PR square and AB square upon PQ square also. So this is what is the proof of the areas of similar triangles theorem. So remember these theorems are very important theorems as the similarity of triangles is concerned, and they have their own applications in calculations. Okay, thank you. Here in this theorem, don't take this as 1, only count this as 1 and this as 2. There is a wrong double time, we have written 1 here, so cancel this 1, only take this as 1 and this as 2 and this as 3. Okay, remember that. Thank you.